We have come to another question which came into GATE XL-H 2016 and the question number here is 14. The topic of this question is electrochemistry. So first we will read the question, what the question is actually stating. For a weak acid at 298 Kelvin, the molar conductivities in ohm inverse, meter square, mole inverse at infinite dilution and 0.04 mole decimeter cube are 4.3 into 10 to the power minus 3 and 1.0 into 10 to the power minus 3 respectively. The degree of dissociation of the acid is 0.04 mole decimeter cube at 298 Kelvin is. So what is given? What is given in this question is that they are talking about something called as a weak acid. Okay, so it is to note that they are talking about weak acid at 298 Kelvin, and there are certain terms in this question like molar conductivities, which is given in the unit ohm inverse, meter square, mole inverse, and they are talking something about infinite dilution. Okay, so these are the means terms that is coming when we actually read this question. To solve this question, we need to little bit discuss about what they are and what is the concept behind this question. So now first look into that, what is the concept which is actually required for solving this question. So for weak acids, okay, mark for weak electrolytes or like for weak acids or weak bases, there is a law which actually states that how the dissociation of these weak electrolytes will take place in infinite dilution. So the name of that law is Kohlrausch law, that is given by the name of the scientist who actually discovered it. And it states that at infinite dilution, when dissociation is complete, each ion makes a definite contribution towards equivalent conductance of the electrolyte, irrespective of the nature of the ion with which it is associated, and the value of equivalent conductance at infinite dilution for any electrolyte is the sum of the contribution of its constituent ions, that is the cations and anions. So this law is stating that it is stating that at infinite dilution, so you are diluting the weak electrolytes to a level where you are considering that you are diluting it to infinite dilution level. Then what is considered is that the dissociation at infinite dilution of that weak electrolyte, for example, the weak acid or base, the dissociation of them is complete because it is going to an infinite dilution, and each ions which are present in that electrolyte, for example in NaCl there is Na plus and Cl minus ions. Okay, so when they will get dissociated, you get Na plus and Cl minus, the sodium ions and the chloride ions. So in such that case where you have a weak electrolyte and at infinite dilution there is a complete dissociation of this weak electrolyte, then you will get certain ions. So that is stating in this sentence that each ion makes a definite contribution towards equivalent conductance of the electrolyte. So you know the conductance. What is conductance? Conductance is the reverse of the resistance. So this conductance, the equivalent conductance of that electrolyte, how much it will be conducting, okay, or the conductance of the electrolyte, it actually is dependent on the contribution of all the ions which is present in that weak electrolyte. So it is the contribution of each ions which gets dissociated in infinite dilution to the equivalent conductance of that electrolyte, irrespective of the nature of the ion. So it does not matter whether this is a cation or anion, there is no such preference. Each of the ions, irrespective of its nature, will contribute to the equivalent conductance of the electrolyte with which it is associated, and the value of equivalent conductance at infinite dilution for any electrolyte is the sum of the contribution of its constituent ions. So if you want to find out the equivalent conductance of a weak electrolyte or a weak acid, then it will have a positive charge and a negative charge ion, that is a cation and negative charge, and the cation the positive charge and the anion is the negatively charged. Okay, so if you know the molar conductivity of your each cation and anions, which is making the whole electrolyte, then the equivalent conductance of that weak electrolyte will be the sum of this equivalent the conductance or the conductivity of the each ions, that is of your cation and of your anion. Okay, if you sum them, if you take a sum, then you will get the net equivalent conductivity or equivalent conductance of the weak electrolyte. So this formula is quite important. So this formula is important for solving other questions which is coming for the infinite dilution of weak electrolytes. What is more important in to solve this question which I discussed is that here if you see that they are talking about what is the value that we need to find out. We need to find out the degree of dissociation of the acid. So what is the degree of dissociation of the weak electrolyte at infinite dilution? That is actually given by this formula, that is alpha is equals to lambda m divided by lambda naught m. So this lambda naught m is the standard or standard potential. Okay, and lambda m, that is this standard not potential, this is the standard equivalent conductance when you go to infinite dilution. That is at infinite dilution, what is the conductance of your electrolyte, that is given by this delta m naught, and delta m is the conductivity or the conductance of the electrolyte at a particular concentration of that weak electrolyte. It is not in the infinite level. So this alpha is actually directly proportional to this lambda or the conductivity. So this is very important for solving this question. So if it is directly proportional, then it should be alpha divided by alpha at infinity, right? Dissociation constant at infinity, which gives you lambda m divided by this lambda naught m. Okay, but what is important is that this dissociation constant at infinity is referred to as 1. Okay, this is actually coming as 1. That's why the formula becomes alpha equals to lambda m divided by lambda naught m. So this formula is very important for solving our question. Another important thing that I wanted to discuss with this question is that this, which is the dissociation constant. So this is the alpha is the degree of dissociation and Ka is the dissociation constant. If it is A, then it is the acid dissociation constant of the weak electrolyte. It is given by this molar conductivity squared multiplied by the concentration of that electrolyte divided by limiting molar conductivity squared multiplied by 1 minus molar conductivity divided by the limiting molar conductivity at infinite dilution. Okay, so if you know this formula, this will actually help you if in some question they ask you about the finding the acid dissociation constant, then this formula will be very helpful for solving this question. Now let us look into what is the solution of our question. What is given here is this C value is given, that is the concentration of this electrolyte is actually given. So the concentration is this at infinite dilution for a weak acid at 298 Kelvin, the molar conductivities at infinite dilution, and 0.04 mole decimeter cube are. So at infinite dilution, the molar conductivity and the molar conductivity at this concentration of your weak electrolyte is given. Okay, at not this concentration, at this concentration 0.04 mole decimeter cube. So what is being given, that the molar conductivity at infinite dilution of your electrolyte is given as 4.3 into 10 to the power minus 3, and the molar conductivity at 0.04 mole decimeter cube concentration of the electrolyte is given as 1 into 10 to the power minus 3. Now what they are asking is to find the degree of dissociation of the acid. Okay, so again the concentration is given as 0.04 mole decimeter cube as I discussed. So that I have written here. So the concentration which is given of the weak electrolyte is 0.04 mole decimeter per cube, decimeter per cube, and these are the molar conductivities which are being given at infinite dilution and at a particular concentration of your electrolyte, that is this C. Okay, so at infinite dilution the molar conductivity is given by this value 4.3 into 10 to the power minus 3, and at concentration C the molar conductivity is given by the value of 1 into 10 to the power minus 3. Now, since molar conductivity is directly proportional, as I discussed, it is directly proportional to the degree of dissociation. So it is directly proportional to the degree of dissociation. This degree of dissociation is this alpha, which has been asked in your question. And it is directly proportional to this molar conductivity at infinite dilutions. Okay, so this is actually the case in all scenarios, and at infinite dilution the alpha, that is the degree of dissociation at alpha at infinity, is actually equal to 1, as I discussed previously. So the formula became this, the formula that we already discussed, the for degree of dissociation, that is the alpha. So the formula is molar conductivity at the concentration C of the electrolyte divided by the molar conductivity at infinity, that is given by this delta or this lambda m naught. Okay, so already the two values are given in the question. So at concentration C it is 1 into 10 to the power minus 3 at concentration of 0.04 mole, and at at infinity the concentration is 4.3 into 10 to the power minus 3. Just you need to put these values in this equation and you will get to your answer, that is the degree of dissociation which is being asked in this question of 2016 question number 14. The value will be 0.2325. Okay, so the value will be 0.2325. So mind here, there is nothing written that here we need to round off the value. If it was written that we need to round off the value, then we need to round that value, but since it is not written, the answer will be 0.2325 for this question. So for your reference, you can actually follow these two courses which is offered by NPTEL. So the first course is of elementary electrochemistry, and the course instructor for this NPTEL course is Professor Anshuman Roy Choudhury of Aizer Mohali. The link is been provided here. Another course is run by NPTEL, that is the name of the course is electrochemistry, and it is the course instructor of this course is Professor M.V. Sangaranarayanam, and he is from IIT Madras. So you can look into these two courses for your better insights in about the electrochemistry and get some more idea about the electrochemistry concepts, which will be very useful for your GATE exams.